Yeah. So you zoom it. F is equal to m. Okay. Zoom it and scroll it left, right, and up down. You can explain me. Yeah, this is visible. Yeah, you can explain me. Hello, you are not audible.
So can you hear me now?
Yeah. Uh,
Huh. So we can see here that mass is connected to a spring and
yeah.
a
Yeah.
damper, correct?
Mm, mm.
Right one, the force here, the force is, uh, I mean, the
Disturbance.
X is equal to a disturbance, correct? Okay.
Yeah.
The number of degree of freedom will be one.
Yeah.
Then we can see the FBD, free body
Yeah.
diagram. Okay.
Okay.
Uh,
Yeah.
Fs is only the springs,
Okay. See,
force
I got this.
force of
Okay.
spring. Okay.
Go down. Go down. Mm,
Okay.
okay. Yeah. Fine. So
So
finally,
we can see here
what
the
is the
finally the
what transfer function? Now you have to find out the transfer function. So
transfer
what is
function.
transfer function? That is nothing but the
Transfer function
response
is something response
response
upon
upon
input
input. Okay.
disturbance.
So you have to find out x upon f. Okay.
X upon F.
X upon f.
Okay.
X upon f. So I will explain again. Now what is this
Okay.
matrices form? May you have put fx fy. Yeah, that is right. Huh? Now you see my screen. Can you see my screen?
Wait a second, sir. So I will stop sharing
What?
my screen. That would be right.
Yeah. What about? Yeah, yeah. Fine. That was only you wanted to show, no?
Yeah.
You wanted to show that much only, no?
Yes, sir. And
Yeah.
the second part is this. This is the first order system, correct?
Uh,
And the second order system, we will consider the friction, for
Fiction.
friction force.
So
Yes.
that also you show me, no? That also you are done.
Uh, s- no, no, sir, no, sir.
No, you said you are done that also second order.
So I mean that I've done on my book
Hmm.
now, right now, but I have not that prepared that in
Okay.
my, I mean,
Next
myself.
class you show me. Next class you show me.
Okay,
What about
with
Vaidehi? Is Vaidehi, are you there?
Sir, I
Yeah.
didn't do it, sir.
Okay. But did you understood what Hardik showed?
Sir, I understood it, but I hadn't written down the question.
Yeah.
So
No
I didn't do
problem.
it.
Later on, Hardik, you can send me. You understood, no? That is fine. Okay. Yeah. Now, can you see my screen? So, what I want that
Sir, I'm
x
not able
upon
to see the screen.
Hardik, are you able to see the screen?
yes, sir.
Yeah. Vaidehi, is there any problem from your side? Network? Ka?
Sir, I can see it now.
Is, no? Okay. Good. See, what I want, no? I want this x upon fi. Okay. So, just do it. This is what is further transform. You have done it perfectly, all right. That mathematical model is correct. Now, you do it right in front of me. Okay, and see whether you are getting this or not. Just quickly. 1 upon k, w upon gk, and just show me the final answer. Whether you can also do, and if you don't
So,
understand, you please ask me.
so
Hmm.
your screen is shorter. I mean, I can see that.
Sorry. Okay. Is it okay? You want to make it, uh, shall I zoom plus or zoom minus?
Sir, I can see it now.
Yeah. Okay. See, both of you, please see whether you are getting this transfer function. And you have to also give me transfer function for the spring mass damping system. Here some basic algebra is there. This I explained and this I wanted you to do. थोड़ा fast कीजिए. Hello.
Yes, sir.
Yeah, yeah. You're doing it, no? I thought. Did you got it?
So the transfer function, right,
Yeah,
for
transfer
second
function.
order system.
No, no, transfer function for
Then
this. You can see
first
the
one.
screen, no? Yeah, first one. First you do this. This is the answer also. You have to just show me
Yes, sir.
whether
That's the
whether
answer.
you are
Correct.
whether you are getting or not. Did you got it?
Yes, sir. The yes, sir.
Okay. Can you just read it? What you got?
Uh, okay. The answer is that what is transfer function? First thing, it is
Res,
I
res,
mean output upon input. I
uh,
mean response upon
response of
disturbance.
yeah.
Response upon disturbance. Correct.
Hmm,
Then
yeah.
x is equal to one upon k. Correct.
Hmm,
Then it's and fi we can I mean we can get that fi, that is equation of motion.
uh, no, you just tell
Okay.
me what is your final answer. You got answer.
So for second order system I got it, not for
No, no,
first order system.
for
For
this, for
for
this.
this.
Yeah. Have you done it?
No, sir. I'm doing it now.
Whether you also do it.
Hello,
Hello?
sir.
Yeah.
So, can I give the equation now?
Yeah, sure. Show me present.
Okay, wait a second. So, sir, can you see it, sir?
Sorry, I cannot see your screen. Yeah. Yes. Yeah, zoom it, zoom it. X upon Fi is equal to, show me step by step. Ma is equal to Fi minus K. Okay, Ma plus
This is
Kx
the
is
Fi
equal to,
answer.
yeah.
The
So
equation of
X is
motion.
equal to, X is equal to W upon G square X plus Kx minus Fi. Okay, then next step, go down.
This transfer function. Last line. X upon Fi.
No, how did you, no,
I got this answer, sir.
X is equal to, no, I want X upon Fi, no?
Sir, X upon Fi.
Hmm. How did you call this X upon Fi is equal to 1 upon K directly? How you written?
I thought
That is
X
what
is
I,
equal to 1 upon K. Okay.
okay, what I will do, I will, I'll show you, I'll do it. Just give me a minute. Is Vaidehi there?
Yes, sir.
I'll do it.
So, I
Hello,
got my
hello.
answer.
Yeah, I will show you now.
Okay.
So similarly, you have to do. Going to paint now. Can you see the screen? Paint screen.
Yes, sir.
This is the spring and this is the block. This is a frictionless surface and this is the disturbance Fi. Okay. Now because of this block will move by some distance, say x. Okay. So that is my response. And spring will have resistance. So that is your Fs. Okay. You understood this? Whether this figure? Hello? 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 Did you understood this? Hello? 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 Hello?
I think she has a network problem.
You are. I am not audible. I am. I am saying
Sir, you
hello,
are
hello,
audible.
hello.
Yes, yes.
No.
So I
I was
thought
just calling.
I
I
thought
was
you
just
were
calling
calling to
you.
wedding.
No, no. So, net force
So
is
you are
equal to
audible.
Fi minus Fs. You understood this? Net force. This equation. Net force. Hello.
Yes,
Hello,
sir.
Hardik. Yeah.
Yes, sir.
You understood? Like suppose this is a body. Okay. And I am applying 70 kg here. Okay. And there is another 50 kg in this direction. So what is the net force here? Hardik, tell me. Hello. Hardik.
20 kgs.
Ah, be interactive, bit fast. 20 kg. So same here.
Okay.
Now this is Fi and this is Fs. So what is net force? Fi minus Fs. Okay. Okay, Hardik.
Yes. Okay.
So now this net force will be nothing but m into a. So that is equal to Fi minus k into hello
X.
k into x because this is
X.
uh, k into x because Fs is equal to kx. Okay, now ma mass is nothing but W is equal to mg. So m is equal to W upon g,
W and G.
and this is your
D
acceleration is
square.
d square x.
X.
That is equal to Fi minus kx. Okay. Now I will separate this x.
Yes.
Okay, so I will
Transfer
take
the
this here. I will take this
correct.
here.
Correct.
I will also take x common. So what
Common.
I will get x W
W
upon
by
g
G.
d
D square
square plus
plus K.
k, that is equal to Fi.
F5.
Now my transfer function is response upon disturbance. Okay. So
Disturbance.
I will say therefore
X.
x
X
upon
upon Fi
Fi is equal to
is equal to
1
1 upon
W upon G
G. D
d
square
square
plus K.
plus k. Okay.
Correct.
Now what I will do? I will take k
That
common
K.
from here.
Yeah, yeah,
Okay.
common. Divide both of it.
Uh,
I mean both the sides.
yeah. So divide numerator and denominator by k. So here it will be 1 by k,
1 by
and
K.
then here it will
W by
be
G.
1 plus 1 by this. So this is nothing but a transfer
Sir,
function.
G and K.
Sorry.
W by G K.
W by gk.
G K. Correct.
This is the transfer function. Okay.
Yeah.
Similarly, I want it for spring mass damping system. Okay, so spring mass damping system में Fi minus Fs minus damping force,
Minus
correct? No,
FL.
uh,
Damping force. Sorry.
that
Yeah.
is
Damping force.
C
FD.
D X. Okay,
X.
where C is the damping constant and here K is the spring constant. Okay,
Spring constant.
and C is the damping constant. Okay,
Yeah.
so that is what actually I was expecting. Okay, so now that also you can do it
Okay, sir.
uh, as a homework. Now we will go for some block diagram rules. Okay, block diagram. How to represent a system by block diagram. Okay, so these are the rules. Like suppose this is a signal A and this is a signal B. So this is the summation of the signal, that is y is equal to A plus B. If there is one more signal C, then output response is equal to y is equal to A plus B plus C. Is it clear? This one. This is for the addition. These are the rules of the block diagram. Hello? Hello, Arvind.
Yes, sir.
Yeah.
I'm seeing it.
Yeah. Now this can be represented by this diagram. So you have A, you have B, and these are the C. Okay, so these are the input signals. So y is equal to A plus B plus C. Okay.
Yeah.
Now subtraction. Now signals can be positive or signal can be negative.
Negative.
Whether are we there?
Yes, sir.
I think. So did you understood what I showed this spring mass
Yes, sir.
damping
I
system?
understood.
You can take
Yes,
the
sir.
photo. You can take the photo.
Yes,
Have you taken photo?
I'll take a screen.
Photo or screenshot, whatever it is. Taken?
Yes, sir. I've taken.
Okay. So now this what we are studying is rules for block diagram reduction. Now this is subtraction. Now signal can be positive or negative. Okay. Positive means like suppose if your engine is running at say 3000 rpm is the target and if it is running at 2500, so we have to supply more. So that is a negative signal. So if it is minus, here it is minus, here it is plus. So y is equal to a minus b minus c. Okay. Then third rule is multiplication. So multiplication is shown by this a. All right. So y is equal to x into a. Then fourth rule is division. So division is represented by 1 upon a. Okay, so that is y is equal to x upon a here. Then differentiation. So differentiation means y is equal to, this is the operator d by dt, right? So y is equal to d into x, where d is nothing but d by dt of x. Then integration. Integration is opposite to the derivative 1 by d. So y is equal to x upon d. Okay, now see, suppose now here if I want to find out the transfer function. So if this value multiplication may, if this value of this block is say 3, okay, so I can write y is equal to 3x. So what will be the transfer function? Y upon x. So y upon x is equal to 3. Here what will be the transfer function? Y upon x is equal to 1 upon a. Is this clear up to this? Are they?
Yes, sir.
Yeah. Now we'll find out. Huh? Now the just now I showed you this. Isn't it? Transfer function we found out for this spring mass system. Now we'll represent how to represent this by block diagram. Now listen carefully. If you don't understand, please ask. If you understand, then also you say yes. Okay. So this is the block mass W. This is spring having spring constant K. This is the response. This is the displacement X. Okay. So now how do I represent? So this is Fi, that is nothing but the disturbance. Now this is the spring force. So spring force is nothing but Fs. Okay, and since it is acting in opposite direction, we will show by negative. And this is the net force, summation of it. Do you understood this? Are they this diagram to be understood?
So
Hello?
can you please
Yeah.
explain it first?
Okay. I'll explain here now in paint may. Go to paint. And let me erase this. See, this is the symbol of summation. Okay. Hello, Hardik.
Yes, sir. I'm hearing.
Be interactive, otherwise I don't
Okay,
understand.
sir.
Now this is Fi. This is a
Okay.
positive signal. Okay, plus. Now this is Fs. It is in negative direction. Okay, so I will show this by Fs and I will
Okay.
say minus. Okay,
Yeah.
and like suppose if this is 500, this is the resistance force, so 200. So what will be the net force?
300.
300. So that is I show like this. Summation of F is equal to what you did, this minus this, isn't it?
This.
So Fi
Yes, sir.
minus
Minus
Fs.
Fs.
Correct? हो गया ना?
Correct. Yeah.
Suppose if this is 200, like suppose if you have a car here, car hai, and if you are pushing this, say this is 50, another force 70, another force say 100. Somebody is pushing in this direction. So what will be the net force? 50 plus 70 plus 100 and minus say this is 20, right? Frictional
Correct.
force maybe.
Yeah.
So same case. So now this is the net force. Summation of F is equal
Yeah.
to Fi minus Fs. Okay, so this you
Fs.
understood, this diagram. The same is
Yeah.
shown here.
Okay.
This. Okay. So now this net force is nothing but Ma. That is nothing but W upon G d square x. Correct?
Correct.
This. So now x upon this summation of F or error. This is also called as the error. X. This I am taking over here. So that is equal to x upon summation of F is equal to what? This will go down, isn't it? So
Yeah.
that will be 1 upon W upon G d square. Have you understood this? So that is
Yes,
nothing
sir.
but G by W into 1 by d square. Is it clear? Have you understood
Yeah.
this? Yeah.
Yes, sir.
Basic only algebra only.
Yes, sir.
Okay. Now this can be written as G upon D into 1 by D into 1 by D. Right?
Correct.
Correct? Now
Yeah.
we will do the block diagram. Okay. So this is my Fi positive signal. This is my Fs, that is negative signal. I am writing this first. So summation of F is equal to, or error F is equal to Fi minus Fs, that is equal to W upon G d square x. Did you understood this?
Yes, sir.
Now I will do first multiplication. So for multiplication I am taking a block of G by W. Okay, this is I am taking, okay, G by W. Now over here I have W by G d square x. Now this is G by W. So what will be the output here? This W by G d square x into G by W. Correct?
Yeah.
Multiplication, rule
One.
of multiplication. So I will get d square x. Right?
This way. Correct.
Now I will do integration. First integration. So 1 by d. Okay. So d square x into 1 by d. That is dx.
Dy.
Now I will integrate again 1 by d. So dx into 1 by d. So that is my response
X.
x. Fine.
Okay.
Now I want to represent this fs. Now fs is equal to k into x. Correct? So that means
Yeah.
I need to add a block here of k and I will take a feedback signal from this. Okay, in this direction. So now here it is x. Right?
Yeah.
Here it is x. Now if I take k here, so what will be the value here? K into x.
Correct.
So fs is equal to kx. This value of this will be kx.
Yeah.
So summation of f is equal to fi minus kx. Understood?
K.
So this
Yes.
is what is called as the block diagram representation.
Okay.
Fine.
Yes, sir.
Okay. Now another rule. So is this clear? This block diagram? If it is not clear, please ask. And then finally, how do you represent this entire block diagram? We represent this by, this is the Fi. and this is my transfer function, and this is my response. Okay, so x
Yes.
upon fi is equal to f of d, and what is f of d? F of d is nothing but this. Okay,
Okay. Yes.
now another rules for block diagram: if the elements are in series like a b c, then how do you get? So now here this is my x input function, this is a block a, so over here I will get x into a, right? This is block b, so here I will get x into a into b, and since
Okay.
this c, so here I will get y is equal to x into abc. Okay, simple. So how to represent this? By a single block. X is the input, y is the output,
Okay.
and this is ABC. So y is equal to x ABC. Now what is the transfer function here? Output upon input. What is my output? Y. What is my
Right.
input? X. So y upon x is equal to ABC. Correct? Y
Correct.
upon x is equal to ABC. Now negative feedback. Now negative feedback is shown like this here. So I have two blocks, one A. Okay, this is my input signal A, X, and this is my output, that is response is Y here. Okay, now this response I am taking and giving it back here. So this is what is called the negative feedback. This is the block B. Fine. Now this is Y here, Y here, Y here. So what will be the value here? Y into B. Do you agree?
Yes, sir.
Uh, See, this output is Y here. This output I am taking it here and giving
Feedback.
feedback here. So value over here will be this Y which is taken, and this will be YB.
Going to be.
Okay. So what will be the error? Error will be C is equal to this error, C is equal to X minus YB. Okay.
Yeah.
X minus YB.
Maybe.
Right. And
Yeah.
over here the value of Y is C into A. Okay. So C will be y upon a. So now I substitute this, y upon a is equal to x minus yb. So x is equal to y into b plus 1. Now I will show this for the positive feedback loop. I will do it so that you understand this. Okay.
Okay.
So now look carefully. Shall I erase this?
Yeah, sir.
So now this is positive feedback. Whether if you don't understand, please ask. Huh? This is my input signal x plus, this is my block A. All right. Positive feedback, that means I will say this is plus, this is C. Okay, and this arrow you have to show this. So what is this? Y is equal to, what will be the value of y? Y is equal to, hello,
X into CA.
no, this is C, this is C, and this is A. So what is the value of y here? Hello,
C plus A.
sorry,
A plus C.
this is C and this is A, this is a multiplier, no?
C into A, sir.
C
It's
into
AC,
A,
CA.
CA or
It will be
AC. Now
CA.
C, okay, CA. Okay, now I am taking this. Okay, and since this is positive feedback, I will join it here like this. Okay, this. Now I will put a block B here because it's a positive feedback. This is block B. Okay. What is the value here? Y. Okay. Now what is the
Yes.
value here? What is the
Uh,
value here? This is Y into B or BY.
into B.
Understood? This is the value of this block A. We are representing the system. slowly you'll understand. We are representing the system by some block A and block B. This is the gain of that block. This is the gain of this block. Okay, so By. Have you understood this? By? Vaidai?
Yes, sir.
Okay. So
Yes,
now
sir.
this is error C. Now over here you have X. Over here you have YB. Okay. So now you tell me C is equal to what?
C is equal to x plus y.
Correct? Vaidai, right? X plus YB. Because here you have this is YB and this is X. Both are positive. Now from here, what is the value of C here? C is equal to Y upon A, right?
Yes, sir.
So therefore Y upon A is equal to X plus YB. Now what is the transfer function? Response upon input, correct? No, disturbance. So that is we want to find out Y upon X, right?
X.
Okay, so how to do it now? Tell me. This is what is shown here. Okay, so C is equal to X plus YB, that is equal to Y upon A. Okay, so now what we'll do here? X is equal to. So what is X? Tell me. X is equal to Y upon A minus YB. Correct?
Correct.
Now Y I will take common. So that is 1 upon A minus B. Okay. So therefore Y upon X is equal to what? 1 upon
1
1
upon
upon A
A
minus
minus B.
B. Okay, understood this? Now take LCM. So y upon x is equal to, this will be 1 minus AB, and this A will go up. So A upon 1 minus AB, transfer function for a positive feedback. You understood this?
Yes,
1
sir.
minus AB cross multiply divided
Yes.
by A, and that A
A.
goes up. So
Up.
A upon 1 minus AB, and y upon x is nothing but the transfer function. Whether
Yes, sir. I understood.
so you can take screenshot of this. So this is for the positive feedback. If it is negative feedback, then this becomes A upon 1 plus AB. Okay.
Yes, sir.
So for the negative feedback, it is positive, and for the positive feedback, it is
It is
negative.
negative.
Okay. Now same uh, rules will apply for this spring mass damping system. Now look here. I'll just take 2 minutes more. Now this is spring stiffness. This is C is the damping stiffness. This is the weight, and this is my input disturbance. Okay, so now I will represent this by block diagram. So this is error function, right? So
Yes.
now this is Fi. Fi is nothing but disturbance. Okay. So here I have now two resistances. One is spring force and another is damping force, right? So that I will represent like this. One is your FF and another is your FS. One is your FF and another is your FS. So first let me show FF. FF is nothing but the damping force. So here I will get Fi minus FF. Okay. Then second, that is Fi minus FF minus Fs. Okay. Now this is nothing but the net force. So net force is W by G d square x, right? Now first multiplier I will take g by w, so d square x. Then second multiplier, that is integration 1 by d, so I'll get dx, then 1 by dx. Fine. Now this is kx. Fine. And I will have one more block of c, so that is nothing but c. So c into dx, so c dx. So that I will show like this. Fine. So I will show this. Have you taken screenshot of this? I'll delete this.
Yes, sir, I've taken.
Yeah. So this is my Fi. Okay. And this is my FF. FF is nothing but the damping force. Okay. So what will be this here? Error will be यहाँ पे Fi minus FF. This is positive and this is negative. Is this clear? Vaidehi?
Yes, sir.
Yeah.
Yes,
Now,
sir.
yeah. Now I will add here the spring force, that is Fs. Okay. So now what will be the error here? Summation of F is equal to Fi minus FF minus Fs. Is this clear? Hello. थोड़ा fast बोलो.
Yes,
Is this
sir.
clear? This. Okay. Now this net force, this is what is this net force. Okay. So this net force is nothing but W by G d square x. बराबर है?
Yes.
So now my first multiplier I will take G by W. Okay. Now this into this will give you what? This into this will give you what? Hurry up.
This, this,
D square
1 by D.
d, d square x. Correct.
Yes.
Now the signal is flowing. Now I will integrate. So 1 upon d. Okay. 1 by d into d square x will give you what?
Dx.
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 Okay.
Dx.
Now again I will integrate 1 by d. Now this into this will give you what?
X.
That is
X.
nothing but the response. Okay. Now I have to
Yes.
complete this. Okay. So now Fs is what? Fs is equal to what? Bolo फटाफट. Kx, isn't it?
Kx.
Yes, sir.
So I will add a block here of k. Okay. I will join this and this. Okay. So I will take a feedback. This k, this x I am taking here. So what will be the value here just next to this block? Kx. Okay.
Kx.
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 Kx. So this is
Hmm.
Kx. Okay. Now what about this FF? This is the damping force. So this I will take it from here. Okay. यहाँ से ले लूँगा. Okay. And I will put a block of C here. Okay. That is nothing but a damping constant. So ऐसा लिया and this is. Now what will be the value here? What will be the value here? C into dx. Correct. So
Dx.
C dx. Okay. This is what complete block diagram represent. Now if you want to solve this, how I'll solve this? So you have represented the system, okay, by block diagram. Now
Okay.
how to solve it? Now you can combine this these two first, G by W into one by D. Okay. So how to reduce it? So from here, this is the diagram. Okay. So look now, this is G by WD multiplied G upon W into 1 by D. Have you understood this? G by
Yes, sir.
WD. हाँ.
Yeah.
ओके. सो ये जो दो ब्लॉक था वो एक ब्लॉक हो गया. ठीक है. और
Yes.
ऊपर सी है और यहाँ पे के है. बराबर है.
Uh,
हेलो.
Yes, sir.
बराबर है. इतना
Yes,
समझा.
sir.
ओके. नाउ what about this? Now this is two blocks in. This is negative feedback. बराबर है. So negative feedback, that means what? A upon, you have to remember, A upon 1 plus AB. Correct. A upon 1 plus AB. Right. So that will
yes,
give
sir.
you this G upon WD plus GC. ठीक है. And then multiply by 1 by D. So ये आपका सीरीज में हो गया. So that will be multiplied. ठीक है. And then now this and this. Okay, that will become again a negative feedback. So you will get this. Okay, I'll show you one, and we can stop here. Okay, so
Yes, sir.
okay, now concentrate. Now ये जो दो ब्लॉक है, okay, so I'll combine this G upon W and 1 by W. Okay, इसको combine कर दूंगा. Okay, so that becomes one block. So यहाँ पे अभी क्या आएगा? बोलो.
G by
G
WD.
by W.
WD.
Okay, so ये दो. This is what is called as the block diagram reduction. ये हो. Now what you have to combine? I said. So you have to combine this and this, or you have to combine this and this. So now we will do some changes, okay? Because
Hmm.
this goes here and this goes here. So what we'll do, we will combine this and we'll combine this, okay? So this iteration will always happen, okay? So just tell me whether you are understood this, what changes I have done. This is nothing but same, okay? Same ही है, कुछ नहीं, there is no confusion, okay? Did you understood this? क्या किया मैंने? ये माइनस है, माइनस एफ है.
Yes, sir.
Yes,
Okay.
sir.
Now these two blocks they are in parallel and this is negative feedback. तो negative feedback का कैसा था अपना a upon 1 plus ab. ठीक है, ट्रांसफर फंक्शन.
Hmm.
तो ये पूरा अभी रिड्यूस हो जाएगा. ठीक है, what is a? G by wd and what is b? C. So a, that is G upon wd upon 1 plus a into b, that is a is G upon wd, okay, into b, that is nothing but क्या है आपका C.
Hmm.
अंडरस्टूड दिस?
Hmm.
हेलो.
Yes, sir.
सो अभी पूरा ये निकल जाएगा. नाउ दिस इज स्टेप 2. ओके, ये दूसरा डायग्राम बनेगा. यू हैव टू शो दिस
Hmm.
दूसरा डायग्राम. मैं तो इधर ही इरेज इरेज कर रहा हूँ. ठीक है, अभी अब इसको थोड़ा सिंप्लीफाई करने का.
Hmm.
सिंप्लीफाई करेंगे तो क्या मिलेगा अपने को यहाँ पे? G अपॉन डब्ल्यू डी कैंसिल, बराबर है डब्ल्यू
Cancel.
डी प्लस
Correct.
जी सी, करेक्ट.
G, sir. Yeah.
ओके, अभी ये पूरा मैं इरेज कर देता हूँ. ठीक है, दिस आई विल इरेज कंप्लीटली. वैदेवी, आई होप यू आर अंडरस्टैंडिंग. तो अभी इसकी जगह मैं क्या लिखूंगा अभी? G अपॉन
G
डब्ल्यू
upon
डी
WD.
प्लस प्लस जी सी. ठीक है, ये लिख दिया. ओके,
Yes, sir.
दिस इज द सेकंड डायग्राम. अभी नाउ दिस एंड दिस दे आर इन सीरीज. देखो, दिस एंड दिस इज इन सीरीज, बराबर है. तो मल्टीप्लाई हो
Yeah.
जाएगा. तो मल्टीप्लाई होगा तो आई विल गेट लाइक दिस 1 अपॉन डी इंटू जी अपॉन डब्ल्यू डी प्लस जी सी. ठीक है. सो अभी
Hmm.
मैं थर्ड तीसरा डायग्राम, दिस इज द थर्ड डायग्राम. So the third diagram will be G upon WD square plus GCD. ठीक है, ओके.
Yes, sir.
नाउ ये क्या है? ये आपका माइनस है, बराबर है, माइनस के यहाँ पे. नाउ दिस
Huh.
इज व्हाट अगेन? नेगेटिव फीडबैक. ये आपका ए है और
Okay.
दिस इज बी. सो अगेन सेम रूल यू
Hmm.
हैव टू अप्लाई, ए अपॉन 1 प्लस ए बी, राइट.
Hmm.
एंड फाइनली यू विल गेट, इसकी जगह ये भी निकल जाएगा एंड देन यू विल गेट वन फॉर्म. ठीक है, ओके. So
Yes,
this
sir.
is what is called as the block
Diagram.
block diagram reduction method. Block diagram reduction
Reduction
method.
method.
Okay. So here I uploaded this. You see this, you will come to know. Okay.
Yes, sir.
So as a
Yes.
homework, both of you have to do this. मतलब you draw this, represent this by block diagram.
Okay.
Okay, and reduce it, and you should get this result. Okay, which
Okay,
we
sir.
have got it here. पहला जो था ना, by simultaneous equation
Huh.
से किया था ना, ये
Huh.
this this should match with this. I have purposely not shown this here. Okay, so this यहाँ पे ये जो transfer function and this transfer function should be same block diagram. Okay.
Okay, sir.
Okay. Thank you.
Thank you, sir.
And show and WhatsApp
Thank you,
me.
sir.
Okay.
Okay,
WhatsApp
sir.
me in 1 day or 2 days. Okay.
Okay, sir.
So
ठीक.
that
Okay,
I'll
sir.
come to know you are understood or not, and we can proceed because this is for the this will have around 12 marks. This simultaneous equation and this block diagram reduction that will
Okay, sir.
give you 12 marks. Okay, thank you.
Thank you, sir.
Thank you, sir.
So by tomorrow or by Friday, Saturday, you send me. Okay, as early as possible. Do it today itself because now you are understood. No.
Yes, sir.